In this video, I'll cover how to evaluate a piecewise function both from the equation and from the graph. So if we're evaluating a piecewise algebraically, you're going to notice that there are multiple pieces or multiple equations for one function. So that this is my function and it has two rules. So it's important to know when to use each rule. And the way you determine how to use or when to use each rule is based off the inequality or the domain restriction for that rule. So the first rule says use this one when x is less than 0. The bottom one says, hey, use this rule when x is greater than or equal to 0. So I'm going to look at my questions below. The first question says f of negative 3. So I'm deciding, is negative 3 less than 0 or is it greater than or equal to 0? And negative 3 is less than 0, so I'm using the green rule. And all I do once I decide which rule to use is to plug the value in. So 2 times negative 3 minus 4. I'm just plugging negative 3 into the x in the green rule. So I have 2 times negative 3 is negative 6, take away 4 is negative 10. And so f of negative 3 is negative 10. The next one is 1. So again, I'm deciding is 1 less than 0 or greater than or equal to 0. And 1 is greater than or equal to 0. So I'm going to use the bottom rule. So I'm going to do 1 squared, take away 5. 1 squared is 1, take away 5 is negative 4. So f of 1 is negative 4. We usually put the notation in our answer. All right, f of 0. So I'm again deciding less than 0 or greater than or equal to 0. And it's equal to 0, so I'm going to use the purple rule. Square 0, take away 5. 0 times itself is 0. Take away 5 is negative 5. The last one is negative 10. Negative 10 is less than 0. So I'm going to use the green rule. I have 2 times negative 10 minus 4. Again, I just replace the x with the negative 10. And that gives me negative 20. Take away 4. So I have negative 24. Let's try another example. This piecewise function has 3 pieces or 3 rules and 3 different spots where you use those rules or restricted domains. So my function itself is g of x, and I'm going to use the absolute value of negative 3x for x is less than or equal to negative 3. The answer is 4 when it's between negative 3 and 0. And then I'm going to use the bottom equation, x squared take away x, when x is greater than 0. So my first problem is g of negative 5. Negative 5 is less than or equal to negative 3, so this would be the top rule. I'm going to plug in negative 5 in for x inside that absolute value. And negative 3 times negative 5 is positive 15. The absolute value of positive 15 is 15, so g of negative 5 is 15. G of 0 is going to fall into the green rule because it's equal to 0, and that one goes from negative 3 up to less than or equal to 0. And this is a funny one. When you have a rule that just has a number, it's a constant, it just means the answer is that number, so G of 0 is 4. Oopsies. All right, G of negative 3 is going to fall into the top one again because it is less than or equal to negative 3. Absolute value of negative 3 times negative 3 gives me the absolute value of 9, which is just 9. And then the last one is g of 1. 1 is greater than 0, so that falls into the bottom rule. And the bottom rule was x squared take away x, so I'm going to do 1 squared take away 1 since x is 1. This gives me 1 take away 1, which is 0. So that is how you evaluate from the function itself using algebra. The next way I'm going to show you how to evaluate a piecewise function is from a graph. So I've got a graph here, and I'm going to evaluate these different questions, and you need to remember that the inside number is always x. So I'm looking for where is x negative 4. I go to the x-axis at negative 4. This one's actually touching the x-axis at -4. So this ordered pair would be -4, comma 0. So my y value is 0. It's just saying, hey, if x is -4, what's your y value? For number 10, I'm going where x is -2. That's right here. Look for the graph. I have 2 spots at -2. You're going to want to use the closed circle because the open circle is not included. So the closed circle, the y value is -8 because this point right here is -2, comma -8. So the y value is -8. At 1, go to the x-axis. There's 1. Find your ordered pair. That's 1, 4. The answer is 4. At -5, that would be right here on the x-axis. Here's my point. That point would be -5, -1. So I'm at -1. Okay, here's another graph. So we have j of 4. This one's j of x. So j of 4, x is 4. Go to the x-axis, find 4. Look for the graph. There's my graph. It's crossing at 4, 2. So my y value is 2. All right, -4 is right here. There's my point. There's also an open circle, but remember I'm going to want the closed circle. That point's -4, -4. -4 is the answer. J of 0, I have an open circle only at 0. There's no part of the graph that's included there. There's no closed dot. There's no like middle of a graph. It's just the open circle. So we say undefined. So if you only have an open circle or nothing at all, then that would be undefined. At -9, I'm down here. This point is -9, -6, and so my answer is -6. All right, let's practice another one using algebra. We have another example here where we have 3 pieces. This is the function I of x. It could be any letter. The different letters in front of the parentheses just mean it's a different function than the one before. So g of x is different than f of x is different than h of x, and so on. So it's just different letters to separate them. We have 3 rules. The first rule says the answer is 3 when x is less than -1. The second rule says use -4x plus 2 if you're between -1 and 6. And then the last rule says use absolute value of x minus 3 if x is greater than or equal to 6. So we want I of 2. I of 2 is going to fall in between -1 and 6, so that's the green rule. And the green rule says to plug into -4x plus 2. So I'm going to plug in 2. This gives me -8 plus 2, which is -6. And again, I like to leave my answer with that fancy notation. I of 6. 6 is greater than or equal to 6, which is the bottom rule. So I'm plugging into the absolute value of x minus 3. So 6 minus 3 is 3. And the absolute value of 3 is 3. Next, I want I of 10. 10 is greater than or equal to 6. So I'm using that bottom rule again. 10 take away 3 gives me the absolute value of 7, which is just 7. And then the last one is at I of -1. So there's 2 rules that have a -1 in them. The top one and the middle one, the yellow and the green. I of -1 is going to work for the green rule because it's equal to -1 there. The top one says it has to be less than -1. So we're never actually using the yellow piece in these examples. So I have -4 times -1 plus 2, which gives me +4 plus 2, which is 6. So if I had been given something like I of -2, which would be less than -1, then the answer would be 3. So we didn't use the top rule, so there's an example of when the top rule would have been used. Last one, I have evaluate graphically again, and so this one's R of x. It says R of x is graph below. Find the values given that, and then there is a typo here. Let's make all of these be R's. R. And probably if you're watching this, I may have fixed it already. So I have -4 Find my point is at 2 because that's the point -4, 2. When I go to -2, go up, find the point, that's also at 2. When I am at 1, there's only an open circle. There is no part of the graph there other than that, so this one's undefined. And then lastly, r of -5 is right here, and this is going to be using the closed dot, not the open dot. We want the closed dot, which is also at 2. And this is how you evaluate piecewise functions.